So here we are at our final section that we're going to cover for the final exam review, section 14.4, which is consumer surplus and producer surplus. Okay. And what you want to do is you want to approach this one as area between two curves. That's really all it is, but it's an applied problem. So when we have a consumer surplus, the amount that the consumer's willing to pay, remember at the beginning some are willing to pay higher, but as we, to get more people involved, the price generally will go down. And so the surplus is if we start with a lower price, we've got this room between what the consumers were willing to pay and what the actual price is. So what we always have is we have two functions. And the way we're going to give it to you is we're going to have it set up in terms of the price. A lot of times the demand is set in terms of Q, which is the daily, because that's what could get measured, daily sales. But these particular problems, we're going to give you that equation solved for price. Okay, so that's one of the functions we're going to use. The other one is a constant function. It's the price. We're going to set the price at a particular amount. Y equals an amount. That's a horizontal line. And calculate daily, if you sell, use DVDs. So this is the price they're going to sell it at. So our two functions are P equals 15e to the minus 0.01 Q, and this P, this is a special P that they're using that they're going to set it at. We called it P bar before, so we'll just keep with that. It's going to be P equals 5. So these are our two functions. We'll graph one as Y1, graph the other as Y2. You'll see that Y1 is on top, so we'll do Y1 minus Y2, but I'm going to just, we're going to kind of wait a little bit till we graph it so we see. Seeing is believing, right? Then just like when we did area of two curves, the first thing we're going to need to find is an intersection point because that will give us the Q bar, the particular demand that we're going to be sort of integrating tell. And typically what we do with these is we'll go from 0 to Q bar, because that gives us our integral, our interval, and our limits of integration. Okay, so let's first go ahead and take a look at the graph, the two graphs. So we'll put in Y1, and I've got my Y1, Y2, the subtraction of the two functions. I've got that set up from when I was doing the area of two curves already. And notice they're turned off, so I can leave them here forever, literally, or until the batteries run out. Let's see, we go to second. Natural log is your E. There we go, E to the X. We put minus 0.01, which is a 1% change, a decrease is what it's telling us. And then our Q is what we're going to call X. So basically just remember P is the Y values of the graph. Q is the X values of the graph. And the second one is just Y2 equals 5. I'm going to go to now this starting at 15, I think that's going to give us a Y value of around 15, and then it's going to be coming down, right? Price will come down, well, because it should usually start higher and then come down. Well, we'll just see. We'll go with 20 instead of 40. And then our X's, again, we're usually safe that we're not going to charge less than $0. But what would the price be? Well, we know the price. Wait, these are our Y values. I got to rethink this, right? P is our Y value. So we go down to 5. Maybe if I put in a 0 here at 0, that would give me a 1, that would give me 15. So I think we're okay with the Y's there. So now the X values, the X value, that's the Q. So how far out will that demand go? I'm not sure, so let's go to 50. I don't know. Let's go to 50. So 0 to 50. So that's demand. Let's see what that looks like. So yeah, here it's coming down. I actually got to go out further. They don't intersect yet. Actually, not second. So we go back to window. We're going to make our X max. Let's go to looks like 100 should do it though. Maybe 150, but I think 100 will do it. We see the intersection just does it. So I'm going to go 125 just to get a little bit further out, and so we see what's actually, oops, what did I do wrong there? It's something, let's take that off. We don't need a 1,250, just 125. Okay, so we come out here, we can find that intersection. So we find intersections with second calc, number 5. Enter, enter, enter. We get the intersection point is 109.86123. So what we're going to be doing is we're integrating from 0 to 109.86123. I use all the decimals because I want it to be accurate. And what we've found is that we've got y1 on top, q minus 5 dq. So we would integrate this. The other way we can find this is we could set the two equal to each other, right? That's where they intersect. So you could say that 15 e to the minus 0.01 q equals 5. Okay, so then we want to solve for q, so we divide both sides by 15. We get e to the minus 0.01 q equals 1/3. Take natural log of both sides, and what does that get us? This comes down. Natural log of e is just 1, so this whole side just becomes minus 0.01 q. This is natural log of 1/3. And then we just divide by negative 0.01. Now you're thinking right now we got a negative, but how do we end up with 109? It's because the natural log of 1/3 also is a negative value. We'll show you here in just a moment. So you could use that as your limit, but let's come back to our screen here. And let's plug this in. Natural log 1 divided by 3, close the parentheses, and then we'll divide it by negative 0.01. When you divide by a small decimal, you get actually a much larger number, and that's why that's going to happen. Natural log of 1/3 is negative. Negative divided by negative is going to give us positive, and watch, just like magic, we get our 109.86123. Of course, they go to 2, and then it got rounded up. So we're a little bit more accurate that way. But some systems, if you needed an exact value, we would just leave it like this. Or actually, we might go negative natural log of 1/3. If divide by 0.01 would be the same thing as multiplying by 100, right? So you could rewrite this in a more nice fashion. Let's get that out of the way. Let's get this out of the way. So if you wanted to, you might see this. So we could put that as the limit if you wanted to. But what we're going to do is we're going to go ahead and do this. So what are we trying? Calculate consumers. So the surplus that we're going to end up with is a dollar amount. We're going to round it anyway, right? So let's bring the calculator back. Remember what we do. We've got our y1, y2. We've got y1 minus y2. So y1 minus y2. We're going to turn that graph on, y1 minus y2. We're going to turn the other two graphs off. And we're going to see this new graph, which is really that graph just moved down 5. So now we're getting the area between that curve and the x-axis, which there is a tool to do that, second calc, number 7. The lower limit is 0. That's if zero demand, right? Wait, let's see, P is our, Q is our X value. Yeah, 0 demand, 0 sales at that particular price. Enter all the way to 109.86123. So that's how many sales we would make at that given $5. That's so usually if we were charging 5, we would have made this sale. And usually we would slowly bring it down to get more and more sales, is what that's saying. We'll put it all in there. Notice it fills it in all the way to that point, and we get that our answer is 450.69, and those are dollars. So that's the consumer surplus. We've left that much money in the consumers' pockets, and hopefully they'll go spend that money, because this is money they would have been willing to spend on DVDs, but since we charged a lower price, we're leaving money in the community that they can go spend it somewhere else. That's the idea of a consumer surplus, or maybe those folks can save some money for later, but this is surplus money in the consumer's pocket. So it's a way of building wealth in the community. That's the kind I like. Okay, so there's our answer there. Okay, but notice, just treat it as a area between two curves. Graph the two curves, this function and this function, and then see which one's on top. And that way you won't get waylaid by trying to figure out whether it's a consumer surplus or a producer surplus, because we'll be doing both. See? Got a producer surplus. We're going to approach this one exactly the same way, but we're going to see that the graph will lead us into understanding which one's on top. Okay, the producer surplus for a supply equation. This with a p-bar at 29. So again, these are the two equations we have. We have a y1, we have a y2. We're going to graph them because we need to find where they intersect anyway. We could also do it manually by, 13 plus 2q equals 29. That's what we're doing. But we're going to do it graphically because we got to graph it anyway. But do it both ways just to, again, get some practice and make sure that, sometimes you make an error. You know me, I'm error prone on entering things, so it's always helpful for me if I do two different ways, especially on exams. If you've got two different ways to check things, when they don't check out, then there's an error in one or maybe both. That's my problem. Sometimes it's in both of them. But so I'm going to turn this one off for now, right? So here's my two functions. I'm going to graph them. Which one's going to be on top? Can you anticipate? You were right. It should be the y equals 29 should be on top. The producers are, what they're doing is they're charging more than they would be willing. That's how they get a surplus. The $29 is more than they would have been willing to do because maybe it's a luxury item or it's a high popularity item for something. So they're actually able to get more money, and we can't see much because window size. So let's just go with the zoom standard and see if that helps. So here's this function. Okay, y equals 29 is going to be a horizontal line at 29. That's a y value. So let's make our y max. Let's go 35. I'd like to be a little bit above it. And our x max, remember that is, x max is number of units. It's the supply. Sorry, I just have a really dry throat today for some reason. So we're kind of guessing what Q is going to be. Let's go. Well, actually 29, remember, if I'm, well, I don't, anyway. Let's go for 100. And then let's just graph it. Let's not think about it too much. That goes up. There's the y equals 29. Actually, yeah, I could have. So this little triangle here, below the 29 in here, because past this point, it looks like the producers want to be able to charge more. But in this little region, this would give them a surplus. Okay, so that's what we're looking at. And since I went to 100, I think I could probably go to 20. Maybe even less, but so we've got that one, we've got this one. Yeah, could have gotten less, but so we need to find this point of intersection. This is y equals 29, which is y2, and down here, and again, I forgot to show you, but you can hit the trace, and you see which one it's on. It's all visual. We're on y1 now. We can see it's below y2, which is y equals 29. Okay, so good to take a look at those. We want to find the intersection. We go second calc, number 5, and then we go first curve, just enter, 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 and we get our intersections x equals 8. Okay, so what we've determined from all of this, our setup is we're going to go from 0 to 8. y2 is the first function, so that's 29 minus the second function. And again, be sure to put the parentheses around it. We're going to do this with the calculator, graphically, numerical. There's a whole level of mathematics called numerical analysis, numerical methods, and that's what they do. They use computers, calculators, to numerically come up with answers. And in the real world, those numerical answers are they're usually right on time. We don't need exact values with logarithms and e to the x's. We need numbers that general people can understand, that we could report directly to the folks we're working with, and maybe even to ourselves, that are a lot more meaningful. Okay, so we've got this one. So what do we do? It is y2 minus y1. And so I might y2 minus y1. Come back to the y equals. Remember, I like to turn these off. Again, it's not a requirement, but it makes it a lot clearer to do, and then just choose the right one. I want the y2 minus y1. And hopefully you remember how to do it. I'll just give you a quick setup here. It's from the vars key. So if you have a blank one, you go to vars, y vars, function, and then you choose which one you want. y1 minus y2. Okay, function, we'll do y2. So there we go. I don't want it there, so I'm going to clear it out. Okay, so that was just an example of how did I get these y2 minus y1s, in case you hadn't watched the other videos yet. We should have, but hey, we're just, we all learn in different orders. So y2 minus y1. So now when I graph it, all I've got is one graph. And it's the combination of y2 minus y1. And notice it's sort of inverted it. It's still that same triangle. So I'm going to get the same area. It's just got it now. The area I want is the area under the curve and the x-axis. That's what allows my tool here, second calc, my integration tool, to find it, because the tool is set up to just find the area between one curve and the x-axis. That's the way it's designed. This that we've got set up here works perfectly. So then we want to go from 0 to 8. So lower limit, we're going to put as 0, x equals 0. The upper limit, we're going to put as x equals 8. We put 8, x equals 8, enter. It fills it in, shows us that we're getting the right area and that our area is 64. That's a surplus of $64. Now, this, sometimes this stuff is a big factory, so that's, millions of units. So, that'd be cool. That'd be $64 million or something if we had, but they don't tell us that. They're just saying that might be a garage unit. This is it, and this is only, he makes 64 extra bucks by selling it at $29, rather than the lower value that you would like just to get started. You usually, okay, I want to sell a few, then when it gets out there, I'll up the price, because that's really what, what's driving my business. So here's our surplus. But again, notice how this is really just area between two curves. I was at 14.2. It's really that same process, just now it has meaning. We can actually put some meaning to it. Okay. And I'll let you watch the videos. And so again, they want producer surplus, but we don't have to worry too much. We've got P equals this. We've got a P prime of this. So what we're going to do is we're going to graph the two, and we'll see which one's on top. That will help us with the subtraction. If you remember producer surplus, it's the price that's going to be, we're offering at a higher price, so that'll be on top. So we're kind of anticipating to see P equals 14 on top, this graph to be below it, and then we find that intersection point again. So we just come back here, go to our y equals. We're going to clear out these two functions, and we're going to turn off this second function here, this y2 minus y1, because we're not actually, we probably could have left it on. We're going to, that's the one we will use, but I want you to know that from the start. And again, you might enter this in a different order. So 2x to the 1/3, 1 divided by 3. Now make sure, depending upon your calculator, when you enter this, some of you may need to put a parentheses around this 1/3 so it's all up in the exponent. If your exponent key doesn't put it up into the exponent like mine does here, make sure you have a parentheses around that. Otherwise, it's taking x to the first power and then dividing the answer by 3. It's not putting that divide by 3 up in the exponent. Just a technicality, but a big technicality. This one I like, just y equals 14. Okay, so let's think of our window. Y equals 14 is kind of at the top. And again, if you don't, you can always play with this. 35 is probably fine, but we could also go with 20. The x max, I'm going to bring it down to 10. I think that's, and we graph it. Let's see what ends up working. So we get this sort of cubic look to it. We've got to go out a little bit further. So this is our surplus here, and notice we don't have the intersection yet. So it looks like it's kind of slowly going up. I'm going to go out to 50, just a guess. And again, a lot of these you just have to try, and that's why I encourage you to work as much as a homework, work it again, work similar problems. Looks like we've got an intersection, but you know me, I'd like to see a little bit more. Let's go to 100, and so that we can clearly see that there's an intersection between the two. Okay, there's a nice, I see an intersection. Okay, there's our surplus in this little triangle, and if we do the trace key, which one are we on? Okay, so this one is y1. It's below y2. So we're going to go with y2. And again, what we decided to do, it's always good to label what you're doing here. So we're going to want y2 minus y1, right? And we're going to go from 0 to wherever they intersect. And again, we could find that by setting the two equations equal. And that's what's going to be q bar to the 1/3 equals 14. So we could solve this for q bar, or we could just come here and find its intersection. Second calc, number 5, enter, enter, enter. Tells me the intersection point is q bar equals 42.875, which is like 7/8. I used to do mortgage loans, and you get to know the eighths tables because the interest rates are by 1/8%. 0.125, 0.25, 0.375. It's been 30 years, but sometimes you just never forget those things. Okay, so what we're doing, and again, in the bigger scheme of things, is we're taking 14 minus 7 plus 2q to the 1/3. And notice my parentheses so that this negative will distribute through if we were to do it by hand. We're going to go from 0 to 42.875. So that's what we're doing. We're going to do it numerically. What we do first is we come and turn off the functions so that they don't graph. They're still there. They're still being part of the calculation. We want y2 minus y1. So that's where you have to be careful here. I mean, if we do the wrong one, it should become obvious. We'll be under the x-axis and we'll get the right value, but it'll be negative. So that's not as big of a deal, but it's a deal, right? So we can see here, they're going to get the area under this curve. And since I'm going to do that afterwards, I'm going to do it backwards just to show you. We get the same value, but it's negative, and then we'll be okay. So we do the number 7. We're finding the integral. Our limits are going from 0 to 42.875. We see. Well, I had to think a long time. I was going, what's going on here? Okay, so our answer is that the producer has a surplus of $75.03. I don't know, I feel pretty proud of myself. I figured out how to get this calculator to always stay on top. Probably a simple thing for most of you folks. But if you get this calculator, it's kind of cool. It's a free download, wabbitemu.org, nonprofit, I guess, or maybe they want some money. And then you go to options, and you can set on the options to display, the general, always show it on top. And it finally started working. So cool stuff in there. But that's our producer surplus. Okay, so again, this is just area between two curves, and there we go. Oh, I said I was going to show you, what if I did it backwards? I just wanted to show you that it's pretty foolproof here. The surplus is always going to be a positive value, so if for some reason I inadvertently chose the wrong one, and I go to the graph, look at this. I've got the same area, but it's underneath. It's going to give me a negative value. I'll still do the same thing, right? But hopefully you see, oh, wait, I've got the wrong way. It's underneath. But I'll show you, even if you go ahead and say, I don't have much time left, so let me put the lower limit of 0, the upper limit of 42.875. And again, it took a couple minutes. It's going to fill in underneath, and our answer is going to be the same 75.03, but it's going to be negative. See the negative. And I just say, oh, I went the wrong route. It's not really negative. It's just going to be that. Okay, so you can compensate with these things. So if you're paying attention closely, you could get by with just y1 minus y2, and then figure out which one's on top, and that it's actually going to be positive. But play with these things, understand these things. You folks are going to be the ones controlling the business, the supply chain, the economy of all the rest of us. And when you do your job well, when you find creative ways to make our resources available to everybody, and so everybody has enough, that's really what the human endeavor has been about. Sometimes people look down on business people. I've been a business person. I believe the humanistic and the business side are not different. They're the same. Why do we do business? So we can live, survive, thrive, and have amazing lives. So that's what you're working towards. And we need you to understand the mathematics behind it, because as you change things a little bit mathematically, sometimes down the road, it makes a much bigger change, on our trajectory. Just even a few degrees can make a difference between, being up here, being down here, or maybe being down here. So it's important. And That's why I want you to understand the patterns in the mathematics, the overall trends, how a change in rate has a tremendous effect on how things are going to happen down the road. And that's what calculus is all about, the rate of change. The second half of the course, which we're going to focus on here for our 13 and 14, it's all about accumulation of how much that rate of change allows us to accumulate, or to, which can be good or bad. Again, an oil leak, we don't want to accumulate a bunch of oil in the oil out in the environment, so that's not a good thing. But we would like to accumulate wealth within the community. We would like to get business practices that allows a surplus, a consumer surplus, so that the children have something, more tools to learn from. They all have socks and clothing that is something that they can be proud of, that they have something to look forward to. And that's what I'm counting on you all to give to the world, is work hard to understand these things and come up with creative solutions that allows all of us to have everything. Why not? We should also, on the humanistic side, and not become greedy and want so much, but on the business side, why can't we provide everything that's needed for life, the basics? So I'll stop now. Some of you have probably already left, but those that haven't, I just wanted to take this last video as an opportunity to say thank you for making this my first semester teaching 210 at ASU with 100 students. Actually, we started with 109. We're ending with 92, which I guess is okay. I would have liked to have ended with 109, but these things happen. I'm teaching it again in the fall. At least I am scheduled. So if you have some friends, if you enjoyed the process and you have friends that are needing to take it, please recommend them over and have them come introduce themselves to me and say, hey, I'm Joe's friend, or Victor, or I'll remember some of your names and as they describe me. But this is why I teach, is the relatedness, and to try to motivate you to do your utmost to make this world a better place. Not a better place filled with more greed, or not a better place for just a few of the people, but a better place for all of the people that are alive today and those that'll be alive later. For my culture, we look for 7 generations. So the way I was taught it, we always have to understand the 3 generations before us. And I was fortunate enough to meet my great-grandparents on my mom's side. So I've got my great-grandparents. I know them. I met them. I talked with them. My grandparents, my parents, that's 3 generations. I've got my generation to look out for. And then I've got the next 3 generations down to the great-grandkids. I don't personally have any great-grandkids. I don't have any kids except for you guys. And most of you guys are pretty old kids. But anyway, look out for that, the next coming generations. Take the lessons from the last few generations from within your family and the motivations they've given you. And always remember that your generation counts too. Remember to give yourself that benefit, give yourself that love, give yourself that respect, because only when you're doing well are you able to truly give back to the community. Give to yourself as you're doing now. Continue to respect yourself and your needs. Do well, be safe, and let's rock this world.